Hey everyone, welcome to another webinar. This is a sort of timely webinar around some news that's been out there around a particular study, but I wanted to talk about broadly more about raw cannabinoids, which are the acid forms of cannabinoids. So today we're going to talk about that paper, go into a deep dive about acid-based cannabinoids and kind of our perspective at it here. So what are these cannabinoid acids? We're going to just kind of go over the basics of what they are, and then we're going to specifically dive into the paper that you guys have probably run into now, the Forbes article and all those different media outlets. And it's called Cannabinoids Block Cellular Entry of SARS-CoV-2 and the Emerging Variants. So I'll give you my thoughts on that and sort of how we can talk about that. And then I did want to touch on the media response from that paper, and then already some rebuttals around the paper and talk about those limitations of the studies. And then finally just talk about how to interact with the customers around this topic. So hopefully this will kind of explain why we think acid cannabinoids are important, and then also just sort of the limitations to some of the study stuff. And it's a little bit of curbing enthusiasm, but it's also just sort of like the bottom line of how the scientific community is going to be viewing these sort of things as they pop up. So first and foremost, what are these things? So what's interesting is that these acid forms are actually the natural occurring cannabinoids that are on live plants. So if you see a cannabis plant out in the field somewhere, those compounds that are on the plants are these acid forms of cannabinoids. So they're basically unprocessed. So the raw hemp stuff, as you guys know, we've kind of called that out, but if you're not aware, the raw hemp is where these are right now. So decarboxylation is a fancy word for basically just saying we're eliminating that acid portion. So CBDA becomes CBD. And those are basically neutral forms is what they're called. So these cannabinoids that we all see, that we sell every day, that we are around, CBD, CBG, CBN, Delta 9, those are all neutral formed ligands, basically. So they're neutral. That just means that they aren't acids or basic. So, and at this point, they're in isolate forms, and we're basically trying to become exclusively extracts in these acids as well. So, but as of right now, these acids have not been commercially viable and really haven't been out there. But we were going to try to put this out this year because of some of this excitement around these compounds, and I'll talk about it as well. Just kind of looking into the future as to how these will have implications. And finally, the most important thing about, in my opinion, these acids is once you smoke them, they convert over to these neutral forms as well. So smoking, it's impossible to get an actual intake of these acid forms when you have heat to it. So decarboxylation is what converts it over, and that happens when you smoke or vape any of these extracts that have these acids in them. So again, I keep on saying decarboxylation. What does that mean? Basically here you can see there's this green raw hemp here, and this is what happens after decarboxylation. So every cannabinoid will have like a decarboxylation temperature that it's optimal to convert it to. Once you reach that, it decarboxylates. So this is an example of CBDA decarboxylating over to CBD. So decarboxylation is basically just elimination of this carboxylic acid. You can think of it as like CO2. Basically this pops over and you get a nice decarboxyl group. So that's all decarboxylation is. It's a fancy way of saying we're eliminating this group of CBDA and turning it into CBD. So there's really no difference. You can see the same premise here on CBGA. This carboxylic acid group just gets kicked off, and the rest of the compound is the same. So the difference between acids and the neutral ligands are not that crazy. But up until this point, there had not been many pieces of data showing that these acids are more important or less important. We basically just know that it's a lot more stable to work with these neutral ligands, so that's what we've been doing. And by stable, I mean like you can use heat on them and they won't convert. So again, I think some of the important conversations come around this where it's like people are getting a little bit too carried away with these acid forms. So I've seen some things where it's like CBD and CBG are less natural because the raw hemp has it in this form. Well, less natural is sort of like an ideology. It doesn't actually have any fundamental root in does this help humans more or less. So we've already seen that obviously those other cannabinoids do a lot of profound work. So to just write them off and say the acids are just fundamentally better because they're more natural is not a good way to look at it. They're tricky to formulate with these acids because you have to stay below 120 degrees C in most cases. So gummies and things like that you would have to do at colder temperatures, which is really hard to do. So again, the formulation challenges around these are stark because these are much more expensive because not many people are using these acids. So you have to basically tell some hemp provider, hey, we want it before you do all the stuff that you do to sell to everybody else. So just do this for us. And like let's just have these acids, and then all of a sudden you go all the way to manufacturing, you accidentally heat it up too much, and then you've just made a CBD product but much more expensively. So there's tricks around these, like cannabinoids, where pressure could be important. Maybe in an acidic environment it keeps them all stable, but these are sort of the barriers to get into this space. But again, what I think, and I'll talk more about this, but what I think is the positives of this is that these acids did perform differently in this exact context of this COVID entry into human cells. So there is now some good literature examples of how these are useful. These acid forms are useful. So again, I think that we should accept all types of cannabinoids, not be particular about which one is better or worse, but we should think about these acid forms as just adding another option or another cannabinoid, like the difference between CBD and CBG. These are now the difference between CBDA and CBD. And these acids are going to be different and target things differently, and they might work for some people, they might work for others. So it's just like the normal gambit of when we get introduced to something like THCV that has its own set of properties, these acids have their own set of properties as well. They're fundamentally different. They act similarly, but they're not quite the same. The same way that like CBN and CBD are calming, there is some degree of difference, and some people react starkly differently, and we still need to know more about that difference, but that's really the takeaway from these acids so far. So let's talk about this paper that came out. There's a lot of enthusiasm around it. There's a lot of bold statements. We'll go into that. But let's just talk about what's the big picture. What is the big deal about these viral variants? And I'm going to be as non-political, apolitical as possible. This is a scientific perspective about things, so I'm not going to talk about things in that capacity, but I'm just going to talk about why virus variants and things mutating and antibiotic resistance and how that's a problem, and how pharmaceuticals have kind of created this problem, and I don't think that they're suited to sort of get out of that hole. So what's the mechanism? How does this work with COVID? How is it proposed? And then we're going to go into the limitations of the study, so there's going to be a big focus on that, but then the final is like, what should you take away from it? And eventually we're going to talk about how you interact with a customer around it, but just your own takeaway from the studies. We'll talk about that as well. So again, I would say be proud about this. Like this stuff is relevant because it's just, these are important problems that they're trying to solve with all these different compounds, and hemp turned out to be one of the few that showed any action compared to all these other botanicals that are out there. They didn't just study cannabis stuff, they studied other plants, and hemp and these acid forms hit a whole different threshold that they did not think was achievable with plants. So again, it's a new potential. We need more information and stuff like that. We need more human trials, and I'll get on talk about that as well. But I would also just ultimately be excited that there's this potential that's there. So just briefly, the important issue is virus mutation or antibiotic resistance, and how this sort of happens is you have two different viral entities that come into a host cell, and they recombine, they find genetic benefits within one another. So, influenza virus 1 comes out, it hits the host cell, number 2 comes, they kind of speak to each other about how to navigate these cells better, and then all of a sudden a new virus comes out. And when I say speak together, I mean biochemical signaling, and antibiotics are a key component to that. Antibiotics have one very simple method for action where they're killing some of these viruses. So if they can avoid that one action, they can pass that on to different versions of the virus and then compete at a better level. And that's where antibiotic resistance comes from. That's where these COVID mutations are coming from in some ways as well. They naturally will mutate over time, but having these mutations happen is really we know that that's going to happen going forward. But what's the interesting part about this is these acid forms seem to not to be they're very resilient against these mutations. So they tried it against a couple different variants and they worked just fine. Where the vaccinations, for example, are having trouble with all these different mutations and variants, and they have to make some new ones that are targeted towards other ones. So again, it's more like a whack-a-mole situation with pharmaceutical routes, where this one could be a broad approach that could target the entirety of the cell lines of mutations, which would be huge for antibiotic resistance or viral changes. So again, this is sort of like the perspective that I have, is like these viral loads are interacting with, let's just say that these blue pieces here of biological systems in our body and our cell walls are kind of, they interact with the virus as they go in. Maybe they kill it, but some of the viruses, they can interact with this stuff and understand, oh, this is what they're trying to do against me, and compete against that. So again, with all of these complicated pharmaceutical interventions that we've had, with all of these different issues of taking all of these single molecule drugs, these biological systems and viral systems are from nature and have complexities. And something like plants and botanicals have been targeted as good solutions because they're so complicated. Like they have terpenes, flavonoids, all of these different components that are complex enough and resilient enough to sort of combat some of these issues. So the more complicated your molecular build for killing a virus, like in this case, the better success you could have. Where if you just had one single approach, those mutations are more likely to happen. So again, kind of an aside and sort of a deep dive into the greater context of this, but I think that's a big component of what the paper's trying to talk about. So how does this actually work? It's actually not that complicated. So if you know anything about COVID, you know that the spike protein is where it is targeting, and basically what happens in these contexts is that CBDA and CBGA bind very nicely to the spike protein and sit and block that site. So that basically means that when COVID comes by, that cell, that spike protein that it's supposed to be targeting is already loaded up and cannot bind. So COVID basically blocks that viral load, and if it binds that spike protein, it can proliferate and create COVID across the body, and that's the incubation period that we see, and then all of a sudden it expresses COVID across the body. So to me, I kind of think of it like a molecular sunscreen. You're putting in this compound to sit on this site, and you're blocking it from being absorbed. So it's almost like how sunscreen blocks UV radiation. You can think of this mechanism as, okay, I'm going to go attach to the spike protein so that COVID can't go bind to it. And again, it's a complicated plant extract. The individual isolates were not as strong. They showed that comparison as well. Unfortunately, most of the data is on their isolate forms in the paper. But again, having a more complicated plant structure can lead to some really important immunity for mutations down the road. So what's the limitations here? So there are a lot of them. So as much as and we'll talk about the headlines and how to sort of talk about this, but unfortunately this has some limitations around, this was an in vitro study. So in vitro means it's grown in a laboratory basically. They'll mimic and recreate the virus, and they'll add in the CBDA and CBGA directly to the cell tissue, and they'll allow it to sort of incubate and sit there for a couple hours. So it is not really mimicking real world experience. Like if CBDA were to get absorbed into the human tissue like it's proposed at the levels that it's proposed, it would sort of have to interact with it for hours at a time. So we know that water soluble, for example, might be diminished over that time period, or oils might not be enough absorption over that time period. So there's some issues with how it's created in the lab and sort of how it mimics real life. And the other issue is that like COVID has many different area points where it can enter the body, and having one sort of area where it's just perfectly blocked may not be enough, and we don't know if it's going to be enough at that point. So again, a concentration, how long it's in that human tissue is the issue. And the real answer is that this is not done in humans and animals. And in the simulation, although it's really great and it shows its potential, it doesn't give us the real world, like how does this work with our products? How would this work with 5,000 milligrams of CBDA tincture or something like that? So there's a lot more work that needs to be done. But I think what the takeaway is that there is a new potential where these acids outperformed other cannabinoids, other botanicals, and they bound perfectly to the spike protein and showed a possibility of this actually being something in the future that could be a great barrier for viral loads. And I do want to say this isn't just SARS-CoV. I mean, this has implications for a lot of different sort of viral diseases that are coming from this same exact sort of mechanism. So the fact that we can see it working in COVID in this model at least shows to me that there's some implications of this working on different viral situations. So like even like the flu, as it mutates over time, there might be some utility of it binding to that directly as well. So I think it's just interesting to see that all of these different components of hemp could sort of be introduced to the body at once, and you may get some varying benefits down the road on a ton of different viruses, not just COVID. So again, what are the key takeaways? Those are the limitations, but the key takeaways for me, the positive news of this, these acids are completely different than the neutral ligands. They need to be explored. The other benefit I've been talking about, viral mutations and antibiotic resistance, is a big problem. I think there was a consumer report that said last year that there were more deaths due to antibiotic resistance than there were like any other cause of death in the planet, because these things are just working on modern medicine over time and they're breaking down and people are dying from things that they weren't dying from just because antibiotics can no longer protect them. The third sort of situation is that the concentration of cannabinoids and the area that it occupies in the body seem to be very important. So the load and the concentration of it is going to be key going forward, and real-world human trials are the best way to look at this. So what we need to be doing now and what they are doing with all the follow-ups is doing human trials. So all of that stuff will come very soon. So let's talk about what happened. So this all happened almost 2 weeks ago. They released it, and then the Forbes article hit about, a week ago. And you can see all these different things. Cannabis sativa can be prevented for study finds cannabis compounds prevent infection. So again, you take a look at the media and how they're going to look at this. They're basically looking for clicking titles. They want people are aware of COVID. The cannabis part of thing is sort of surprising. If you're not following cannabis news very much, so it could be the very first exposure of people understanding that cannabis has the therapeutic potentials. But again, this is directly from the FDA. It says, while this is exciting news for the hemp industry, the FDA has sent dozens of warning letters to manufacturers make medical claims about their products. If claims are made about CBGA or CBDA and the product's ability to block COVID, even in light of the OSU report, the FDA will consider it an unapproved drug. So again, and then they just go into marketing claims around it. So they're tapering their expectations. They don't want people to think that this is a COVID cure that is being marketed as. And again, it's not a COVID cure. It has COVID potential, and we need to see more, but it's not as far as you can go down the road of saying, you take this, you will never get COVID, right? That's what the FDA's nightmare is to have things come out around that. So again, this is not a COVID cure, and I also wanted just to mention that we are making a tincture around this. We moved it up from what was going to be later in the year at launching, and this sort of pushed it up because there's going to be relevant, consumers looking for these products, whether they think it's a COVID cure or not, or whether they want to take it or for that reason or not. I think what we're trying to do is design it so that it has a long-term effect. It's not just COVID-based, so we are adding immunity and other things like that to it. But that's really the approach, is that this is going to be sort of a wellness, immunity, hydration, vitamin D, vitamin C, vitamin B, and some of these other components in there that make it more of an acid wellness product. And I think that that's important because after this study's done, this will still be a very good thing to take during flu season or other times like that when you're looking for higher immune responses and you're looking to get those daily wellness items. And also has a hydration component as well. So at the very least, if you had COVID or were recovering from something like COVID, taking something like this could help with getting those much needed daily vitamins that you need when your body's immune system is under attack. So that's sort of how we're positioning it and how we're talking about it internally as well. So, and again, the final thing, the media stuff that we need to think about is they have a ton of therapeutic potential, and they probably will have a lifetime of impact. That this is not the first thing that we'll talk about how acids are interesting and how they have different properties. They're going to be fundamentally different because their chemical structure is acidic, and that is one of the reasons that it bound perfectly to the spike protein, is just that the chemical properties of them are patently different than the neutral ligands. So again, this is straight from the Forbes article. So it says, study finds cannabinoid compounds prevent infection by COVID-19 virus. And what they're writing about has the nuance that I'm talking about, but the headline itself is not the same. So again, you just have to be wary about headlines and reading articles and understanding where we are in these, and not to go too far or overstep and overreach and talk about things like cures or prevention before we even look at a human model. So, but I thought this was a really good explanation of the viral mutation piece of it. So these variants are well known for evading antibodies against early lineage SARS-CoV-2, which is obviously concerning given the current vaccination strategies rely on early lineage spike proteins as the antigen. So again, this is sort of came out from Omicron, Delta, and all these different variants. The vaccine, the very first vaccine, targeted all of those beginning spike protein variants. So our data shows CBDA and CBGA are effective against the two variants that we looked at, and we hope that that trend will extend onto other existing future variants. So they did notice that there was no difference between a variant specific spike protein binding and another one. So that is really good news. That probably means that there's enough chemical diversity in the plant material to navigate these mutations properly, and it may be a better therapeutic approach in the long haul down the road. So again, exciting things. You can think of things like supplements or, I don't know, all these different viral load things, but at the very least what we can do is try to provide these cannabinoid mixtures and wait and see how the research shakes out and try to adapt and adjust from there. So here's the rebuttal. So Project CBD, I don't know if you guys saw this part, but basically they asked a COVID scientist, and I was lucky enough. So here's the link as well. If you just type in Project CBD antiviral hype, you can read the entire article. But the researcher, his name is Matt Helms, and I actually sat down and spoke with him on the phone Friday, and we kind of went over his thoughts. He's very interesting and is not really tied to anything. He's just been doing pharmacokinetic research on anandamide in the body and how it changes, but he knew a lot about human tissue cultures. He's a biochemist, so he studies these relationships of how much of the body can absorb cannabinoids, what areas, how much is a meaningful milligram, nanogram amount. So anyway, we kind of got to discussing this, and his biggest issue was that we were like an order of magnitude higher in this lab-created procedure than what he's measured in humans. He did admit that maybe water solubility or higher milligrams would be an important way to take a look at this. So we're going to probably work with him to try to figure out some of these questions to see if we're on the same order of magnitude as the study with some of our product development. But again, the biggest thing that he saw was not having a full system with these acids coating the body in all these different tissue areas, and then just not having a high enough concentration for it to be meaningful. But he did say that he's not, against the idea of its potential, and that there were some really exciting real-world studies that are coming out around this that might prove him wrong and might be entourage effect related. So we both sort of lied in the middle of like, I'm probably more pro that this has a lot more potential than him, but he's also kind of thinking about what is the future of this, and how do you get meaningful concentrations of the acid forms to the right areas where COVID could enter the body. So again, this is sort of the same rebuttal that we had talked about earlier of it not being human trials and all that stuff, but just wanted to point out this is what one of the industry experts in this area said about the findings, and I do think it's important because he had no benefit for coming out and saying this. That he's well into the idea that CBD and all these other cannabinoids work fantastically in the body, and so we talked about some of his other research. So he's definitely pro-cannabis. This doesn't come from like a pharma angle. He's just a researcher that kind of wanted to point out that the concentration levels were lower than what would be expected. So with all of that complexity, how would you interact with customers about this topic? So what I'll first say is that hopefully you're not going out and soliciting customers on this topic. Hopefully what's happening is that you're getting a bunch of new customers interested in acids, or returning customers who are now starting to understand that these acids have potential as well. So I would say when that happens, you can just kind of talk about the limitations of the study like we just did, but then also just talk about the excitement around the study as well. Like, it's cool that the acids have different properties. I really wish that study was done in human trials, but it shows that there's some good promise behind it. Those are some examples of just talking about the study with a customer without saying, this is for COVID, you should use this for COVID. So there's definitely some good ways that you guys can talk about the study, be knowledgeable about it, but also not sit there and tell them something that can potentially harm them in one way or another. So I would just hammer the home on that it needs more real life examples, and we're hoping that comes out soon. And you can also tell them that they're ongoing right now, the human trials at OSU and a bunch of other COVID trials across the country. But the main takeaway is that these acids are different, and I think what's interesting as well is that this extract conversation. So these isolates seem to be not performing even nearly as well. So again, whenever we do our formulation, we're hoping to have full extract versions of all of these acids, which would be unique again. So entourage effect just relies on this complex chemical mixture, and that's what we're hoping with all of these extracts. So hopefully we'll be able to differentiate. Right now the market is just flooded with acid forms of isolates that were probably going to be way less active than the stuff that we make. So that pretty much wraps it up. There's also a short distilled version of this webinar where we just sort of take out the highlights of the webinar and put them together for you guys to have a bite-sized version. So if you went through this and you're kind of confused, there's going to be a recap on this entire topic. So really appreciate you guys. Hope you guys have a great end of the month, and we're really excited about this stuff, and we'll keep updating you as stuff comes out. So have a great one, guys.